Hello and welcome back. This lecture is continuation to our last lecture. In last lecture we were talking about undetermined coefficient, and this method we use to find out the particular solution of homogeneous linear equations. Undetermined coefficients. In last video we talked about two rules. Rule number 1 was if fx and its derivatives doesn't have any common term with yc, means no term of fx or its derivative, so I should say or its derivatives satisfy associated homogeneous equation. I'm just writing Ly equal to 0 doesn't satisfy the associated homogeneous equation, then our guess for yp is going to be a linear combination of all independent terms. All independent such terms and their derivative. Okay. Next rule we discussed was, suppose we have an equation Ly equal to f1x plus f2x. None of them are 0. f1x and f2x are non-zero. So to write down our yp, it's going to be yp corresponding to f1x plus the particular solution corresponding to f2x. Today we are going to talk about the third rule, if rule 1 doesn't apply. So this rule is when we have a duplication, the case of duplication. If fx or any term, or if any term in fx or its derivative satisfy the associated homogeneous equation, then what will we do? So what we will do is we will multiply it, we will multiply by x power s. Okay, so suppose we guessed yp1 and we saw that there is a duplication with yc. So we will multiply yp1 with x power s and we call that yp, and this s we will choose such that this s is the smallest number so that yp and yc doesn't have any common term. Okay, let's see one example to make it more clear. Okay, so let's take one example. Y double prime minus 3y prime plus 2y equal to 4x e power 2x plus x. So first step is to write down the associated homogeneous equation and find out yc. So here our characteristic equation is r square minus 3r plus 2 equal to 0, and we already solved this previously. You will, okay, let me just quickly write it down. R minus 2 and R minus 1 are two factors, so R is either 1 or 2. These are two roots. So our complementary solution is C1 e power x plus C2 e power 2x. This is our complementary solution. Next, what we are going to do is we are going to list fx we are going to list linearly independent terms in fx and its derivatives. Okay. So our fx here is four x e to the power 2x plus x, right? So let's list the terms. So the first term is x times e power 2x. The second term is x. So let's first write down corresponding to x times e power 2x. If you take the derivative, you will use the product rule. You keep first one as it is, take the derivative of second one, you will get 2 times of this term. We are not worried about the constant multiples, so you'll get this term. If you take the derivative, the next you will keep e power 2x as it is, and derivative of x is 1, so we have e power 2x. Okay, so these two are two linearly independent terms corresponding to this. For the second, we have x and 1. So our first guess for the yp is ax e power 2x plus b e power 2x plus c times x plus d. This is our yp1. But wait, there is a catch. This, we have e power 2x in yp and we have e power 2x term in yc. So there is a duplication. So we need to multiply by x power something. So here these first two terms were corresponding to x times e power 2x, and we have a duplication, so we need to multiply by x power something. So if we multiply by x, we will get ax square so the duplication is in the second term. So e power 2x is here and e power 2x is here. So we need to multiply by x and we will get this. Note here we are just multiplying by x to the factor which was corresponding to x times e power 2x. And there is no duplication now, so this we will call our yp. So whenever you want to write down, whenever you want to finalize your choice for yp, make sure there is no duplication with yc. In yc we have two linearly independent terms, e power x and e power 2x. In yp we have linearly independent terms x square e power 2x x e power 2x, x and 1. So there is no duplication. So we can go ahead and plug this yp back in our equation to calculate our yp double prime, to calculate this coefficients. So we will calculate yp prime, yp double prime, plug in back into the equation, find out the value of ABCD and calculate our yp. So I'm going to leave it for you, and your final solution yp is going to be, okay, let me write down the value of ABCD also. So I am leaving it as exercise to verify that A is equal to 2, B is equal to -4, C is equal to 1/2 and D is equal to 3/4, and then you will get your yp is equal to e power 2x square minus 4x plus x over 2 plus 3/4. So this is going to be your yp. Okay, let's recap. So whenever we have a duplication, like here we had for e power 2x, we have e power 2x in yp and we had e power 2x here, we multiply by x power s. This s we choose such that there is no duplication left, smallest such s. Okay, so the only thing we need to learn in this method specifically is how to find the journal form of yp. Once you have the journal form, it's very easy to calculate the coefficients by plugging your yp back in your equation. So let's discuss some example how we find out, like some more example to make it clear how we find out our yp. So our next example is, now we are going to write down the journal form of yp only. Y double prime plus 2y prime plus 5 equal to e power -x cosine 2x. This is our characteristic equation for associated homogeneous equation, and the roots are -1 plus minus 2i. If the roots are complex, we write down the yc as, okay, we have c1 times cosine 2x plus c2 times sine 2x. Next, after finding out your yc, write down linearly independent terms involved in fx and its derivatives. So the first term is e power -x cosine 3x. Next term can be e power -x sine 3x, and if you take the derivatives again and again, you will get the same terms. If you will see, there is no duplication in yc and in these linearly independent terms, So this is the case of no duplication. So our yp will look like a times e power negative x cosine 3x plus b times e power negative x sine 3x. You can plug this yp back in your equation to calculate a and b. Next example. If y double prime minus 2y prime plus y equal to e power x. So our characteristic equation over here is r square minus 2r plus 1 equal to 0. So r equal to 1 and 1 are the roots. If we have repeated roots, our yc looks like c1 plus c2x e power x. Our next step is to list down the linearly independent terms involved in fx and its derivatives. So there is only one term e power x, and this term is repeated in our yc. So in our yc we have two linearly independent terms. One is e power x, other one is x times e power x. So this term is repeated in e power x. So this is case of duplication. Now if you multiply by x, you will get x times e power x, which is also a term in yc. So that's why we need to multiply by x square. So here our yp will look like a times x square e power x. Okay, so let's recap what we learned so far for undetermined coefficient. So first, suppose Ly equal to fx is our non-homogeneous equation. Then what we do is we write down, so first our solution look like y equal to yc plus yp. So first step is we write down the associated equation, or I'll simply say Ly equal to 0, associated homogeneous equation. Write down the characteristic equation and find out your yc. Once you get your yc, list all linearly independent terms involved in fx and its derivatives. There are two possibilities. If First possibility is you have a duplication with yc, or you have no duplication. If you have no duplication, you can go ahead and write down your yp as the linear combination of your linearly independent terms. If you have duplication, you will multiply by x power s only to the factor where you have duplication, like corresponding to the f. So suppose there are two f1x and f2x, and you have a duplication for f1, so you will multiply x power s only to the terms which are coming for f1x, okay, and then you will write your yp. So let's make a table for undetermined coefficient where we cover the general forms. So if our fx is a polynomial a0 plus a1x m degree polynomial, then your choice for yp is going to be a0 plus a1x amx power m. Oops. This is going to be your choice for yp. If there is a duplication, you need to multiply by x power s. Okay. If you have your fx, this is your capital Fx. If your fx is a cosine kx plus b sine kx, even if you have only sine kx or cosine kx, a or b, one of them can be equal to 0, your yp will look like a cosine kx plus b sine kx. Suppose you have only cosine kx as your fx, then also your yp is a cosine kx plus b sine kx. And if there is a duplication, we will multiply by x power s. If your exponential function is multiplied with a power cosine kx and b power sine kx, then what we'll do? Then our yp is xs e power nx times the same, oops, I should copy it. Okay, never mind, a times cosine kx plus b times sine kx. These things you can easily verify by listing down all the linearly independent terms. If you have a polynomial multiplied by e power nx, you will get x power s. If there is a duplication, e power nx times the same thing over here. Okay, so we saw the case polynomial, sine cosine, polynomial multiplied by e power nx, sine cosine multiplied by e power nx. Now we will see polynomial multiplied by sine cosine plus b times sine kx. In that case, our choice for yp is we write the choice for Pm. We write the choice for Pm and we multiply by cosine kx with plus sine kx times, this time we need to change the coefficients, say b0, b1x, bm, x power m. So basically, and we multiply by x power s if we have a duplication. Okay. So basically this table you can easily make by listing down all the linearly independent terms of your fx and its derivatives. Okay. So we will stop here today, and in the next lecture we are going to see one more method about for finding out the particular solution, and I'll see you in the next video. Bye bye.